Then instead of using that Boolean algebra simplification, what we were using some laws. There are 9 laws we have learned, and those laws are used to simplify the Boolean expressions. And for simplification, now you can use the Karnaugh maps instead of using that laws. So also you can transfer some logical statements, or you can use the truth table into a Karnaugh map. So actually the truth tables, another way of representing is what we call as the Karnaugh map. And also there is an arrangement, the binary values 0 or 1s within the map that helps you to visualize the logical relationship between the inputs what we give, and from the betweens inputs we get an output in a truth table. Those outputs only will be represented in a Karnaugh map, and then from them we can group them and get a Boolean simplified statement. So this was introduced by, as I said, this is Maurice Karnaugh. He's an American physicist, famous for a Karnaugh map, and he was working at the Bell Labs in 1952 to 66, and he developed this in 1954. And he was born in 1924. When he was 30 years old, he created this, and now this is the latest picture I found in the internet. Okay, so that is the history of Maurice Karnaugh and the Karnaugh maps. I think you can write down this what are Karnaugh maps. I will give you 2 minutes to write down this as what we do in our class here. So you have to write down the notes. Can you write down the notes now? Bhagya, let me
Thanks, sir.
Okay, do it now. Right. When you are using this Karnaugh maps, we have to use in a specific way that these outputs can be simplified very easily. And therefore, there are some rules given in Karnaugh maps how you can map them. So mapping is what you are doing here to get the simplification. So this is one technique here. Without doing any simplification, we map the outputs, and from then you can easily understand what are the simplification there. So instead of drawing a large circuits, logical circuits, we can use the simplified statements from this and get the simplified logical circuit for that. That is what it is going to help you here, right? Okay, shall I move to the next slide? Right. So as you know, there are Boolean logics and logic gates. So the gates will take uh, for their inputs as two inputs, three inputs, four inputs, like that. So the number of inputs is very much taken here. So we don't have to get the basic two input logical circuits for simplification. So whenever comes from the three input logic circuits, then we have to simplify them as we have done in using the Boolean axioms or Boolean laws. We have used more than two there. So therefore, when we talk about this Karnaugh maps, so Karnaugh maps often used to simplify the problem for at least two. So we have to learn only for three variable inputs for your syllabus. Also, there are four variable, five variable inputs also coming there, right? So when you consider about the number of the variables, you know, when we uh, drew the truth table also, we consider this 2 to the power n, the number of cells or the number of statements, what is going to be in a logical truth table. If we have two inputs, we know there are four statements. But in a Karnaugh map, we have to draw cells like this. So if you are drawing two inputs, we must have four cells like this. So the four cells will represent the two inputs. If there are two inputs like A and B, you can name them. So this part is for A and this part, the columns are for B. Rows are taken for A, columns are taken for B, like that. So if you have three inputs, we have to go for eight cells. So this is how you get the two variable inputs. For the two variable A and B is taken here. And for A and B, we can have either 0 or 1. So 0 is you have to write very closer to the A, and 1 is here. And for B, 0 and 1 in this. So then you can have the values for A, 0, 0 here, 0, 1, 1, 0, and 1, 1. So that is the way. So if you are writing them in not in bits, if you are writing in the variables, you can see 0, 0 is A bar, B bar. So when 0 for this part A, so this is going to be A bar. And this 0 is for the B. So the column and row. So first we consider the column, then we consider the row there. So when the column meets 0, this is bar. When the column meets 1, it is the general one, normal one. So this is A bar, B bar. Then you can see the 0, 1 will be A bar, B. We have learned the min terms before this class. So it represents min term 0, 0, 0, 1, 1, 0, 1, 1. And also when you name the Karnaugh map, you have to go in this direction. So I have drawn the direction here. So this direction means it starts with 0 here. Then 1, 2, 3. 0, 1, 2, 3. That is the way you have to go in the direction. So therefore, A bar, B bar here, A bar, B, A, B bar, and A, B. All those are the considered cell values in that one. Then it is taking the min terms there. Also, you can take the max terms. So if you take the max terms, it is coming like this. So max term means the addition here. So you know the min terms are taken from the sum of product, and the max term are taken from the product of sum. So product of sum means here the sums are there, A plus B. Right. Then you can see here 0 plus 1, 0 is A, plus 1 is B bar. Then here 1 plus 0, 1 is A bar, B is 0 there. So while I am explaining, you can write down this. And here A bar, 1 is A bar, this one is B bar. Like that it is explained here. Those are the general representation for two input Karnaugh map. So the second, this 0, 1, 2, 3 shows where you have to name them. So naming is here 1, 2, 3. So this way it is named. So there is no such big issue. You can very easily understand how the general truth table also taken here. So if you are using a truth table for A and B, in that also you can notice same thing is happening. So if A and B is given, we have used 0, 1, 0, 1, 0, 0, 1, 1. So same thing here. So in the first row we see 0, 0. That is what here. Then the second one is 0, 1. That is what you see here. Then 1, 0 is here, and 1, 1 is the last one. So those are the things. The conversion of Karnaugh map from the truth table. Okay. Right. Do you understand? Can I go to the next slide? Or wait? Right. This is 2 to the power 2 cells. 2 to the power 2 means 2 variables are there. Right. If we go for a 3 variable, 2 to the power 3, that will be 8 cells. So the 8 cells are the 3 variable Karnaugh maps. You can notice here AB is taken on the top here. Here you can see the A, B. Two of the variables are taken on the top and another one here. You can exchange them. AB, if you take AB onto the bottom and C, you have to draw it in the other way. So it is like this. If you are taking A, B, C in the other way, at least you have to draw, you must have 8 cells like this. Then you can have A, B here and C here, right? So same thing you can have in the other way or like this way. And also you can exchange the variables A, B, C like this, or you can have the A, B on the top, A on the top and BC in the bottom. So there is no conventional way which one you have to add A and BC. So anyway, this is going to be 0, 1 and this is going to be 0, 0, right? Then 0, 1, 1, 0 and 1, 1. So when you are naming, you have to go with this is the 0th min term, 0 and 1 and 2 and 3. Go in that other way. Sorry. I will show you in a different color there. Right. So this is the 0th one, 1, 2, 3. So you are not going in the same direction. So this is not correct. So you have to go 0 and 1 and come from bottom to top. That is what you name here, right? And this is the way you index them or number them. 0th one, then you have the 1, 0, 1. Then the next column have 2 and 3 in order, right? So therefore it gets like this in this way. And then you have to count from the extreme one. So 4, 5, 6 and 7. Then this will be counted in this way, right? That one you have to remember. Then the min terms are there. This is the 0th min term. This is the first min term. Second min term, third min term, fourth min term comes here. Fifth min term, sixth min term, and seventh min terms are there, right? So as you know, the min terms are, we have named M0 like that. M0, M1, M2. I think you can remember this. M3, M4, M5, M6, and M7 are the available min terms in 3 variable inputs. Yeah. So those are distributed like this. Okay. So when it comes to 3 variable Karnaugh maps, you have to use in that manner. Okay, we'll see if we are using 4 variable, but the 4 variables is not necessary to learn, but as an information I will give you. For your syllabus, you have to deal only with 3 variables maximum, but you can go for at least 5 variables available when you are using. So if it is 4 variables, you have to use 2 to the power 4 means 16 cells. So the 16 cells when you are naming from 0 to 15, you have to use min terms. So the 0, 1, 2, 3 is used in this way. right? Then 4 and 5, the next column, and 6 and 7 from the bottom, right? Then you go to the extreme right, 8 and 9 here, 10 and 11 onto the top, 12 and 13, 14 and 15, right? So in that way, you have to name the index the cells that will give you the min terms. Okay, right. I think you can understand how the mapping, Karnaugh map indexing can be done. Okay. Then when you are using the Karnaugh maps, so the Karnaugh maps is using the completed output you get from one in each of the appropriate cells within the map. You have to take the ones which are adjacent and group them together in twos, fours, and eights. So that is also considered as 2 to the power. So the minimum is you have to get 2 to the power 1 twos group, or it is 2 to the power 2, 4, 4 in one group. So 4 ones, right? Or you have to take 2 to the power 3, 8 in one groups, right? Or the maximum you are using 2, 3 variables, therefore 8 is the maximum you are going to cover. So when you are covering, there are the min terms are considered. You know what are min terms? Min term is the SOP function where the ones are represented. Here you can see in this Karnaugh map, it is only one output is 1. The others are zeros. So only you have to consider this one as the output here. And here, this is the min terms that what I am talking about. But in Karnaugh maps, you have to use not only one single output is not considered to be simplified. There is no way to simplify there, right? So the max terms also we consider as the zeroth ones are considered in the max term. As you know, this is the product of sums you use it. Then the one example I can show you for this is the A, B, two inputs coming through the OR gate. Then the Y will be, as you know, this is going to be the A plus B, right? So the A plus B truth table is like this. When we have two inputs, 0, 1, 0, 1, 0, 0, 1, 1. A plus B is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0. This is the output of that logic circuit. Then if you draw the A to B Karnaugh map, so if we are converting this to this, so you can see, notice A0, B0. So A0, B0 will be 0. Then the next one is A0, B1. So A0 is this, B0 is here. Then it is going to be 1. Then the next one, 1, 0. A is 1, B is 0. A is 1 here, B0 is here. Right? Then it is going to be 1. Then A is 1 here, B is 1 here. So both are 1s. Then we can cover the groups of 2s, but you can't leave this one. Therefore, you can cover it again, right? Then it shows this is the B part, and B part is 1 is the B. So this row entirely takes the B, and this column entirely takes the A there. So therefore, this A is one group, B is another group. So therefore, how you simplify is you have to add these two as A plus B, right? So therefore, it gives the final simplification from the truth table. We can cover by groups of two inputs together and two inputs together. Then you can notice the two groups are covered, and also it is going to be overlap. The same, this number 1 is covered from here on as well as here. So therefore, you have there is a law, rule actually. You can use overlapping the numbers. So to know this, you must adhere to the Karnaugh Map rules. So the Karnaugh Map rules are available. So there are 8 rules: no zeros allowed, no diagonals, only power of 2 numbers of cells each group. The groups should be as large as possible. Everyone must be in at least one group. You can't leave anyone out of the groups. And also, they are the same one can be overlapped in another group. Wrap around is allowed. I will explain one by one quickly. Right. We'll see why how the Karnaugh Map rules are working. So this is rule 1. You can write down and draw them. I have given which is correct and which is wrong. You can see the groups may not include any cell containing 0. So you only cover the groups which are having ones only in the Karnaugh map. So here you can notice the 0 is available. So 1 and 0 you can't make a group. You have to only cover 1 and 1. 1 can be a group. So this is the only correct. So you can't include a 0 into a group, right? So that is the first rule in Karnaugh mapping. Okay. So even if you have other uh, cells are blank, it can be either zeros are there, right? I have just given only this part here. So it can be something else here. You can use a 0 available here, and there are zeros and even 1. So you can't leave this also. That is another rule will come, right? Okay. So then, shall I move to the second one?
Okay, sir.
Okay. So if you have taken down, I'll go to the second one. So groups may be horizontal or vertical, but not diagonal. So you can't go for diagonal like this. Only you have to go in the column wise or row wise. That means row wise you are going horizontally, and column wise you can go vertical. So if you are trying to cover one, two, if it is available once available here, and if you try to cover them as a group, it is not correct. It is not the rule allows you to cover them here. Okay, so therefore this is not correct, and only you are allowed to go horizontal or vertical. No diagonals allowed. Right. Then the third one, groups must contain 1, 2, 4, 8. That is 2 to the power n number of cells, as I earlier explained there. So there may be 4 cells or 8 cells depending on the number of inputs. You can count 4 groups. So when grouping also, you can't group single or odd numbers. So you have to go for even numbers every time. So here 2 and 4. So you can't go for 1, 2, 3, 3 here. And here you can see the zeros and all ones are covered, therefore it is wrong. Or if you are trying to cover like this, you cover the fours for with this one, it is going to be like L shape, or it is not correct. So you have to go for only even numbers, 2 to the power values. Okay. Right. I will just go through this one, these rules quickly. Then I will upload the file for you to take a printout or take the notes. Okay. Right. Then the rule number 4. Each group should be as large as possible. As large as possible means if you are trying to cover the twos here, twos separately, 2 by 2, it is not good enough. So therefore you have to go maximum 4 here, right? Then if you are trying to cover these two in this way, horizontal or vertical, so this is going to be 2 by 2. So don't get the twos. So you go for maximum force here, 4 by 4. Right. So that is the fourth rule. Each group should be as large as possible. Right. Then the rule number 5. Each cell container 1 must be in at least one group. So if you try to group only this and leave this one, it's not correct. So then you must one present in at least one group. Right. So therefore, you have to use the 6th rule to overlap. So this one must be in one group. So therefore, you have to go for the next rule. That means group may be overlap. So therefore, you can overlap the same number of outputs to another group. So if you leave to separate them, like this is separated and this is separated and this is separated, it is not correct, because of the maximum groups also you have to cover, the 4s are there, and also you have to maximum this one, then it will be overlapped. So there is a rule that will allow you to overlap. Okay, that is the 6th rule. Then the 7th rule says you can go for a wraparound table. So the wraparound table is actually it is like wrapping paper. So if you wrap the A4 paper like this way, right? I don't know how to draw this here. So if you are wrapping paper, that will create you some values here, 1 and 1 here. So this and 1 and 1 is meeting. This one and this one, if you wrap the paper, it will meet 1 and 1 together here. So this one and this one will meet when this is wrapped around. Right. So this one, another group. So you can go from a maximum, these two ones and these two ones will meet. Or if you wrap around this way, this one and this one will meet. Right. Then this one and this one will meet. Okay. So therefore, the wraparound, the leftmost cell in a row may be grouped with the rightmost cell. So leftmost cell this is, and rightmost cell will be meeting each other when it is wrapping around. That is number 7. And rule number 8, there should be as few groups as possible. So you can have it few groups here. You can see here the groups. If you are if you are not going for the maximum number of ones to a group, then you can minimize them. Then the number of groups are not maximum groups here. So here we are using 3 separate. It is not allowed actually. So you can go for maximum and few groups. Maximum in one group and groups are fewer then. So few groups are possible, as long as this does not contradict any other previous laws. So this is actually breaking the rule earlier. Right, like that you have to use the rules available, and we'll see how we can simplify a Boolean truth table given for you. Then from this, if you write down the Boolean expression as we have done earlier, you can get the outputs which are giving ones. Then from this you can develop a Karnaugh map. Right, see how you simplify. As you have learned earlier, this is going to be A bar BC, and the last one is ABC. That is the expression what we have from this Karnaugh map. I think you can have a sketch for this one very quickly. Then if I draw a Karnaugh map for this, this is the expression given on the top, right? A bar BC, ABC. These are the two ones you are going to get from here. So then what is A bar BC? Then we have 8 cells. That means A, B, C are 3 inputs. 3 input means 8 statements. That means 8 cells we must have included into the Karnaugh map. Then we consider only the ones. If you mark only the ones is enough, then it will be like this, 1 and 1. So 1 for A bar BC. So A bar is this here, and BC is this 0, 1, 1, 0, 1, 1 is A bar BC. That is 1. Then ABC, A, BC is 1, 1 and 1. And then we can cover the group here. So these groups actually gets the value. So if I say this is A bar and this is A, that is how we represent this. So BC, you can see B0, C0 means B bar, C bar. This B is 0 means B bar, C is the 1. Then this is B, C, and this is B, C bar. Right, now you can notice. So it only covers the entire column of BC column. So therefore, the complete output is BC. Even if you simplify this using the uh, axioms or the laws, you can get A bar BC plus ABC. You can see the BC is common here, right? So I'm just giving only a hint that can be same way it is simplified. And here you can see A bar remaining, and here we have A remaining. So you know A bar plus, sorry, not A bar. You remains A bar plus A is remaining. A bar plus A is 1. So therefore, the answer is B, BC. So the same way you get the answer by the Karnaugh map. You can map it up now quickly. Shall I move it or are you doing this? Are you writing this? Okay. Shall we see another example? Okay. Look at this example. A bar, B bar, C bar plus A bar, B bar, C. That's only the expression is given. Then the expression is taken from a truth table or your scenario, whatever it is given. So as you know, this A bar, B bar, C. So this is A bar, this is B bar, C. B bar, C bar. Right. Then the next one is A bar, B bar, C. So A bar, B bar, C is this. Then only two are there. Then you can cover this. Then how you are going to understand this A bar, and here it is in the one part of the A bar, and you can see which is common. So 0 and 0 are the parts. So if you group break this column, so this is the part of B bar, and this part is belongs to B. So this is belong to B. This part belongs to B bar. And if I get the C's part, you can see in the middle, these are the two are ones, means this is the C's part. And you can see the 0 and 0 part, and the extreme left and right parts are belongs to C bar. right? So here you see the A bar part, and this is A part. So therefore you can understand this is belongs to uh, B bar and A bar, A bar, B bar. So that is your answer. So that is how you simplify this and you get the A bar, B bar as the output. Okay. Right. Then I'll give you another example. Example 2. This is the expression. Okay. Can you simplify using this Karnaugh map and tell what is your answer? Okay. Take down this example quickly. F equal to A bar B, A bar B bar C bar plus A bar B bar C plus A bar B C plus A bar B C bar. Don't use the laws to simplify. Just try this Karnaugh map here. So there are 4 outputs we can see. There will be 4 ones available in the Karnaugh map. Right. You can tell your answers, or you can upload your answer images. Right. I'm waiting for your answers. Have you mapped them? Okay. Girls, are you all there? Are you doing?
Yes, sir.
Mm.
Yes, sir.
Right. Do you understand how to do that? If you have a doubt, you can ask me, right?
Okay, sir.
Uh, Okay, shall we do this in another way? It is not necessary for waiting and wasting our data. I will give you all the examples, right? Then you write down the examples, expressions. I have about 9 examples. I will give you the examples. Then you draw the Karnaugh maps and give the simplification and send the answers through the WhatsApp. Can you? Do you
Can, sir.
understand? Yes. So then it will be okay. Otherwise, it is wasting our time and just waiting for your answers. No. So is it okay, or shall we discuss and go one by one? What do you say? Let me and Samadhi. Once you send the answer, I can discuss whether it goes wrong or something else. What do you prefer?
Okay, sir.
That means, okay, means I will show the examples, then you write down the examples and give your answers by WhatsApp or in the Teams. Which one is easy? You get a photograph and WhatsApp it. No? Is it
Yes.
okay, Samadhi?
Okay, sir.
Okay, right. So this is the second example. I will go through with the other examples. Example 3. Take this down. Output A bar, B bar, C. Don't miss any single one, right? Plus A bar, B, C. You don't have to take down the Karnaugh map here. You can draw the Karnaugh map later now. So only take the example outputs here. A bar B bar C plus A bar B C plus A B bar C plus A B C. Okay. Finish.
Okay, sir.
Right. Then the example number 4. Output is 1, 2, 3, 4, 5, 6 outputs are there. A bar B bar C bar plus A bar B bar C plus A bar B C plus A bar B C bar plus ABC plus ABC bar. Okay. Finish.
Yes, sir.
Then the next one, fifth example, A bar BC plus A bar BC bar plus ABC plus ABC. Okay.
Okay, sir.
Next example, A bar, B bar, C bar plus A, B bar, C bar plus A bar, B, C bar plus A, B, C bar. Next question. Look at this. There are 6 outputs. A bar, B bar, C bar plus A bar, B bar, C plus A bar, B, C plus A bar, B, C bar plus A, B bar, C bar plus A, B, C bar. Got it? Right. Next one. Right. So the 9th example, only the truth table is given. And if the truth table given, you can derive an expression and draw the truth table. Sorry, Karnaugh map. No? Right. Take down the truth table quickly. There are 5 here. That is the importance. How you are going to cover when it is 5. That's a problem here. But your Karnaugh maps will give an easy solution for this because of that wraparound purpose here. Okay. So very easily you can understand from the min terms M0, M1, 2, 3 is missing, M4, M5, M6 are the ones available there. So very quickly you can fill the Karnaugh maps here. So this is 0, 1, 2, 3, 4, 5, 6, 7, right? So this is the 0th one, no? 1, 2, 3, 4, 5, 6, right? In that way also you can fill them quickly. This is 3. So 0, 1, 4, 5, 6. I have given the answer as well, but how you are going to cover them? That's a problem, right? Okay. Then past paper question. Look at this, 2019 previous year. The question was asked, a Boolean function known as a majority function takes n binary inputs and outputs. One, if a majority, at least half of the inputs are 1. Otherwise, its inputs, outputs 0. Let us consider the case when n is equal to 3. There are 3 inputs available, which is the 3 input majority function whose inputs are A, B, and C. The output is Z. Then you are asked to draw the truth table for 3 major inputs. Right? So when you consider here, only 3 inputs are there. How you are going to get the half of them are going to be 1. Half of the inputs are 1 means you can't go for 1.5. So 1.5 means at least 2 of them are true. When at least 2 of them are true, the output will be, otherwise the output is 0. Right? Do you understand what I say? So you write down this question and also try to complete these 3 part questions, Karnaugh maps, and also we have done how to draw the output using the universal gates, NAND gates. First you draw the truth table and using Karnaugh map simplify the Boolean expression. Okay, right. So this is a task for you. Right. First you read the question carefully and easily you can come up with the answers. Okay, girls?
Okay, sir.
Are you writing down the question now? Write down the question.